Hello everyone, New at Games here with another video of the tutorial series of recreating the core version of Getaway Shootout. In the last video, we got computer movement implemented into the game. So now we can have a computer that follows the waypoints that we set for our map, and hopefully it gets to the end of the map just by following the waypoints. And this was just a simple way of getting computer input into computer movement into the game. But there's definitely, again, numerous other ways to actually get computer input or computer movement into a game like this. So in this video, we'll be actually focusing on computer power-ups. Currently, right now, when the computer gets a power-up, such as right now when it collects that bomb power-up, it will never use it because there is no scripts that are calling to use that power up. So that's what we'll be implementing today, is just a simple system to actually have the computer player to use the power up every so often. But before I begin with that today, I'll just fix up some bugs. Actually, it's just pretty much one bug, and that is the computer players currently have their own camera screen, and in the original game, when it's one player like this, it's just one simple screen. We actually don't have cameras for the computer input, so we can just quickly fix that. So I'm just going to navigate to the scripts folder and open up the game manager. And if we go to the create cameras method, we're creating the number of cameras based on the number of players. And that's not what we want right now, because we just want to create the number of cameras to the number of human players in the game, since we just introduced this as a new variable. And if we save that, that should now work to only create the number of cameras for actual human players. So if I bump up the number of total players to the original Getaway Shootout game of 4, and if I click play, we should get 3 other computer players, but only one camera just for the main player. So that is what we want for the camera. And that is basically the only fix I'll do for right now. One thing to note, actually, though, is that this computer input system, there's one thing, or computer movement system, there's one thing that I left out from the original game that I didn't implement in the last video, and that is in scenarios if we had, say, like an elevator in the game that moves back and forth. In the original game, the computer input is a little smart, where it actually waits for the elevator to get down to the original spot, and that is something that can be easily done by introducing a variable to the waypoint, saying something like wait till the waypoint is in range, or doing some other method to just have the player wait till it is ready to jump to. Okay, so now I'm actually going to get into actually implementing the computer power-up input. And I'll actually jump to the original code of the Getaway Shootout game. Just to show you, it actually is very simple in the original Getaway Shootout game. All we are doing is just setting a schedule or a timeout that is just a random range between two constants, basically. And it's determined by the amount of uses that the power-up has. So the more uses the power-up has, the quicker we'll fire the power-up weapon. And basically, we just keep looping until that power-up is depleted. And this is what we'll actually do to implement the computer power-up input for today. So I'm going to jump into that last class that we created in the video before. And that was under player and player computer controller. So this is where we're currently doing the computer movement, and we'll actually just implement the computer power-up input just alongside this movement code. And I'll actually do it pretty much line for line, the exact same as the original Getaway Shootout code. Just basically doing a loop to basically check if we have a power up, and then just keep using it till we don't have a power up anymore. But before I do that, I'm actually good to jump to the player power up, and that's under the player scripts and player power up. Because there's one thing to note right now. Right now we have two methods for actually using player power-ups. The first one being use, and the second one being cancel use. But use is a little misleading because this is actually kind of like starting the use, because we have to actually call cancel use to actually stop the use, because this is set up to set is using to true, as we did in the previous video, and we'll keep looping in the update until we actually call the cancel use. So I'm actually going to rename this to something like start use. And if I save that, I'll have to change it in our player human input controller. And we'll just call start use here. So that's just a naming change, but the reason why I'm doing this is because I actually want to create another method, and I'll actually call this one being the use, and this one will actually use the usable power-up that we currently have. But the first thing to do is just to check if that usable is not null. And then if it's not null, we'll actually use that power-up. And this way we can actually simplify this and just call use if we're using the power-up. So everything should be the same. We just have now another public method to actually just use it one time for that power-up. And this will just be simpler when we're writing the code for the computer input. Instead of actually having to tell the computer input start using, stop using, we can just call it one time with the use, and that should be good for basically all the weapons, but instead of the automatic weapons, those could use a little more logic to actually use start use and cancel use to make it seem like it is holding the trigger and having an automatic weapon. But for right now, we won't focus on that. So I'm going to jump back to the computer input script, and to do this power up logic, I'm going to just create another coroutine, and I'm going to call this power up loop. And I'm going to do basically the same thing as the original Getaway Shootout code, and just loop loop for infinite while we have a power up. So the first thing to check is if, and well, we need access to this player power up that we defined earlier. So player power up, I'm just gonna say PU for short, and then to get a reference to it, since it's on the same game object, we can just do get component power up. And this is where we can actually check if we have, has power up. And this is just a method we implemented earlier that is a bool and returns true if we have a power up. But basically we want to check if this is false, do not continue. And actually it's kind of like the reverse. Continue here means it's a C# thing where, or any actually, a lot of scripts or a lot of languages use this, is continue means you just jump to the next iteration of this while loop. So we'll actually just stick in this part of the code until we have a power up. So at this point we have power up. Something like that. So we have a power up here, and the last thing to do is actually use the power up, and we can actually use that new use method that we just created. And this is like a one-time use, and basically all the current power-ups. This is the way that we currently want to use it. It's not automatic. We just use it once. But before, if we just left it like this, we'd be using this power-up pretty much, well, actually we'd be using it until we deplete it, since we're not even waiting a frame. So if we did something like this would use the power-up every frame. But how I had it in the original Getaway Shootout code is just to kind of wait a set timeout, and this was just a random range. So I'm just actually going to bring this into here. And this way we can actually get the pretty much exact same code in the game. And the only thing that we don't have is this amount of uses. And in the original Getaway Shootout game, this is just the amount of uses that the power-up has. So this will be the amount of bullets the gun has, or the amount of times we can use the health pack, or so forth. And for a lot of the power-ups, this might just be one. But for guns, this would just be the amount of bullets. And one way we can get the amount of power-ups, we could do something like int, let's say amount of uses. We'll set it default to 1. And then we'll actually need access to the actual usable script. So if I go to, let's see, player power-up script, currently we're storing the actual usable power-up as a variable called usable. And we only have that one method of actually getting, if we have the power-up, it just returns if usable is not null. But I'll create another method right below it, and I'll actually say returns a usable, and I'll say get power-up. That simply returns the power-up object, so something like this. That way we can easily get this power-up, so pu.power-up, and this is a usable. But the reason why I'm wanting this usable object, because this is where we can actually check this amount of uses, or in our case this could be the amount of bullets and so forth, because the actual usable script does not implement anything about the number of times it can be used or anything like that. It just simply has the use method and cancel use method. So we'll actually have to cast this into a script that we actually know that has like bullets or anything like that. And if we jump to the side here, if we jump to the usable scripts folder, and if I jump to the gun class, this was the class that has all the weapons, all the guns and projectiles currently implement is this gun class, which is just a usable object. And this is the class that has the amount of ammo, the ammo clip size, and so forth. So we want to know if the current power-up is this type of class. And you can do that in C# by doing something like this, if usable, and then using the is keyword. So if usable is a gun. And this basically means if it's a gun or if it's any sort of descendant of the gun class. So if we made further classes, this would still work. So if usable is gun, and I believe so a new C# or recently new C# method, you can actually cast this into a variable. So we'll call it something like gun. So now we have the variable gun, which is just the usable. This just is like the usable gun object. So if I do gun dot start ammo, that's how we get the actual ammo from the gun. So if I do amount of uses to equal the start ammo, basically that's just going to be the amount of uses that this gun has. And now we can just replace this by amount of uses and so forth like that. Okay, the last thing to do is actually start the coroutine and start the power-up loop. So this was actually going to start the power-up loop every time the player respawns. And already you kind of can see that there's a lot of cases when we don't need to run this power-up loop, especially when the player does not have a power-up loop. So that's what we'll do next, is to basically only run this power-up loop when we have a power-up in hand, because otherwise there makes really no sense to actually be running this coroutine. But for right now, I just want to test if this script works. So if I jump back to the game, check if there's no errors. And then one thing I'll do before we test is just to add more power-ups scattered across the map. That way more players will get power-ups while they're going through the map. Let's create 3 more power-ups, something like this. And now hopefully players should get more power-ups. So now we could play and it's just loading. But it seems like actually we might have got stuck in an infinite loop, and actually I think we did. I think I forgot to break somewhere, possibly. Because it seems like Unity has froze on me. Actually, I'll just restart Unity while I wait. Okay, I've restarted Unity, and I already feel like I know what I messed up with. And yes, so that's simply because we don't want to just continue here. Since this is like a coroutine, basically this would be stuck in an infinite loop because we're waiting no frames at all. So this would just continue looping, not progressing the game 1 frame. It just stay in this loop. And the way to wait to the next frame is doing something like yield return null, which is simply waits till the next frame. And that way we won't get stuck in that infinite loop, and it will only check every frame. So now if I click play, now we have players jumping around, and hopefully we should see, okay, so we see the players using the weapons now. And it should just be, as we defined, just that random timer that when players collect a weapon, they'll just use a random timer based on the amount of ammo that they have. Okay, so that seems to be all functional. And at this point, this is pretty much exactly how the original Getaway Shootout game had. But I'll just do some slight changes now to make it easier to work with, and also just maybe slightly more performant, even though we don't have to focus too much about optimization now, but just to make it more easier to work with. And to do this, I'm actually going to jump to the player power up, and actually I'll just jump back for a second, because as I was saying, we don't really want to run this coroutine. It makes no sense to have it running while we're waiting for a power up. So I think a nice way to do this is to actually be using the callback system, the C# actions, to actually signal the computer input when we retrieve a power up and when we don't have a power up anymore. So the way we'll do that is, yeah, simply just by doing events. So public event, and this will just be defined as an action, and I'll give it to have the usable parameter. And I'm gonna say on power up create, and I'll do another action on power up deplete. So basically these are going to be the two actions that are responsible for picking up and using or finishing the power up. And we'll simply just call it in our code down here. So at the very bottom we'll do something like on power up create, and then check if we have it, and just invoke it with the new usable object that we got here. Something like that. And then we'll implement the second event by just doing down here at the, on power up depleted. We'll actually call it at the start. So on power up deplete, check if we have it, and then just invoke it. Now this way, if we jump to the computer controller, at the start of awake, we can actually just subscribe to these methods. So we can go something like pu on power up create, and then we'll have to create a callback method. So do something like I'll just maybe name it the same thing as the event, something like this. And actually, I forgot, so this is actually a type of usable. And I'll do the same thing for when we use the power up completely, on power up deplete, and simply subscribe to that event as well. And I guess it's good practice then to actually unsubscribe, so void destroy. We'll just do the unsubscribe from these events. And something like that. So at this point, we haven't really changed anything because we're not really using these two new events that we are subscribing to. But now this is when we actually want to only start this power up loop when we have power up create. And then when we deplete the power up, we will actually want to stop this power up loop. So that's the goal of that. And the way to do this is, well, we'll actually keep track of this current power up loop. So I'm doing private enumerator, and I'll call this, maybe let's call it power up loop like this, or possibly power up routine, since it's something like a coroutine. And basically when we want to start this power up loop, we'll do something like power up routine equals power up loop, something like that. And then to start the power up routine, let's do start coroutine and something like that. So instead of actually starting it on awake or on enable, we'll actually remove this. And now we have it right here. And then now with the on power up delete, there's actually a method called stop coroutine. And this is where we pass in the coroutine to stop. So we'll pass it in the power up routine, and that will stop it. So this way now we don't have to check every frame if we have power up, because at this point, if the coroutine is running, we have a power up, because otherwise we would have stopped here on depletion. And we can actually pass in the usable object as a parameter here, and I'll just pass it in to there. That way we can just avoid getting it again, and I'll just get the amount of uses up here, something like that. And there, yeah, so that should be same as before. I'll save it and check. So just reloading. But yeah, as I was saying before, the functionality now shouldn't change, but this should just be kind of a simpler way, and kind of just makes more sense to only be running that coroutine if we have a power up. So we see the player is firing power up. Let's just see if it uses it completely. So used it once. There might be still an error since I'm just looking at this player. Yeah, it hasn't really fired. Let me check. Well, one thing I could do is just actually get this power up and go into debug mode. And if we check, if we go to the bullet gun, if we check the amount of ammo, so yeah, it only used it once. It has 3 ammo left, so it doesn't seem like it's using it completely. Although this, that weapon was being used completely. Oh. Now the player died. So let me just jump back into the script here, see if there's anything out of normal. So I don't see anything out of normal because, again, we're starting it and stopping it on create and on deplete, and we're looping until basically we just keep looping to use that power up. I'm actually just going to pause the video here quick, see if I can debug anything in code. Okay, I figured out the issue. This is actually because when we were refactoring the player power up, we created this new method use, but the way that I implemented this kind of cancel use and start use, the use method, is that the gun actually uses this cancel use to only be fired one button press at a time. That way, for guns that are not automatic, you have to release the button every time. So we actually have to call cancel use after we use the power up. So what I'm going to do for right now is do something like this. And that use method that we made, this one-time use, we'll do the call the use method on the usable object. But then right after it, we'll do the cancel use, like so. And saving this, now this should work. And maybe it's not the most ideal solution. When I was creating these cancel or the start use and cancel use methods, I wasn't really thinking in mind of the computer input. So there could be some refactoring that could be done with that more in mind. But something like this, just having use function that calls the use and cancel use right away, should be fine. So now if I jump to our game, we should see players being able to use the power up multiple times. And I did switch it back just to one player for right now. But yeah, that gun is an automatic gun, so that one actually was working anyways. But for guns like this, the pistol, the player should be able to fire it multiple times like that. And yeah, that should be working. So that is actually pretty much the simple implementation that I do in the original Getaway Shootout game. It honestly isn't that much logic, and I think it's not hard to spot out that it's that simple. But you can definitely take this code a lot further and make it a lot more smart. Basically, you could check using raycast to see if the computer player is in range of a player to shoot. You can do different things. I guess one thing would be to actually check if this gun is automatic, and if it is automatic, actually use that player power-up methods of start use and cancel use to actually just have the player fire automatically. And you could do all sorts of check to see if this usable power-up object is some other type of new power-up object you create in your game. So yeah, there's plenty of opportunity to actually make this logic better for the computer input. But as I found in my games, it's pretty simple that to have simple power-up logic and also just a simple move code, the game actually feels pretty dynamic just with all the dynamic physics going on. So I think it's just a great starting point to have this kind of simple logic that you can just build up upon. So that's actually going to be where I'll stop the video today. And as I was saying, at this point we have pretty much the original Getaway Shootout computer movement and power up implemented at this point. So for the next video, I actually want to get into the actual game logic, which is actually for players to finish. And in the original game, this is finishing at a vehicle or any sort of finish line. And that will be pretty simple. And then we'll also have the players start. So players start at a vehicle. We won't be focusing too much on the animations or stuff like that, but just getting the logic implemented in the game so we can have players spawn and then finally reach the end and have a new level start. So that's what we'll be doing in the next video. Thank you for watching.